Hello, for my math project, I will be giving a lecture video on section 7.1, trig identities. Now, first off, I will be defining what an identity is. An identity is an equation that is always true. For example, the Pythagorean identity, which is that a squared plus b squared equals c squared. And to start off, I will be giving the first three Pythagorean identities, which include and we will be learning how to solve equations using these formulas. Now, first off, I will give steps to follow when verifying identities. First off, look for an identity. Afterwards, turn everything into sine or cosine. Lastly, when all else fails, go on about solving the equation as usual. Now, before we get into our examples, I'm going to give useful things to remember when solving. It'll be useful to have these handy when going about the equations. Now, these all may seem simple, but when your mind is busy with thinking of how to solve the equations, these might slip, and it'll be nice to have them handy. For example 1, we were given to verify sine of x times secant x is equal to tangent x. Now, first off, we are going to look at the equation in two parts, the left-hand side and the right-hand side. We're going to focus on the left-hand side because it is more complicated and it can be simplified. So focusing on the left-hand side, we have sine of x times secant x. And sine of x can't be simplified any further, so we're just going to rewrite it in one large fraction. Oh, I take that back. We will just rewrite it in its own fraction because there's no denominator. We will be putting it over 1, and we are going to multiply it by secant x. which can now be simplified to, well, we can look back to what we have here, and our notes say that secant x equal to 1 over cosine. So we are going to go back to our equation and write 1 over cosine x for in place of secant x right here. And now that we have this here, we can cancel out the 1's and we are left with sine of x over cosine x. And this lastly is equal to tangent of x. And we have now officially verified our solution. Moving forward for our next example, we have tangent squared of x times cotangent squared of x is equal to 1. Now, once again, we will be focusing on the left-hand side versus the right-hand side, but we have the left-hand side, which is far more complicated and can be simplified. So that's where we will be focusing. Now, what can we do with tangent squared of x times cotangent squared of x? We can, it doesn't look like there's any identities clear here, so we can turn everything into sine and cosine. So first off, we will be focusing on tangent squared of x, which is equivalent to, here we have it as equivalent to sine of x over cosine of x. Although this is squared, so we will be having this squared as well. And now moving forward, we will be looking at cotangent squared of x, which is the reciprocal of tangent squared of x. So it will look almost exactly the same as this, but sine and cosine will be flipped. So we have cosine squared of x in the numerator and sine squared of x in the denominator when switching cotangent to sine and cosine. Now we are able to move on to the algebra of the equation, and these will be canceling, and these will also be canceling, so we are left with 1 times 1 equals 1, which is clear. So we have now verified for example 2. Now lastly, we are going to be looking at example 3, which it says to simplify cosecant squared of x all over cosecant squared of x minus 1. Now, first step when solving says to look for an identity. So what we have in our equation is cosecant squared of x. So now we're going to look for the Pythagorean identities and look for the cosecant squared of x, which we have right here in the second identity given. So I'm going to move this identity to where we are solving our problem. And we're going to look at it here. 1 plus cotangent squared of x is equal to cosecant squared of x. Now we are able to manipulate our identity to fitting into this one right here. So we'll be able to change our denominator. It is as simple as subtracting 1 on each side. So now we have cotangent squared of x equal to cosecant squared of x minus 1. And now, since we've done this, we are able to put cotangent in place for our denominator. So moving forward, our new equation is cosecant squared of x all over cosecant squared of x minus 1. Oh, it is not cosecant squared of x minus 1 anymore. It is now cotangent squared of x. moving forward, now that we have this, we can simplify the numerator and the denominator into simply having sine and cosine. So going back to our list of things, we have cosecant squared of x, which is 1 over sine x. So now that's what will be in our numerator. And then in our denominator, we will be replacing cotangent squared of x with cosine squared of x all over sine squared of x. And now that we have a fraction in our denominator, we must multiply by its reciprocal in order to continue simplifying. So I'm going to continue the equation on the corner of this page here. So our 1 over sine x will remain, but it will now be a regular fraction instead of just in the numerator. And now we are taking our denominator and we are going to flip it and start multiplying it instead of dividing it. So now we have sine squared of x in the numerator instead of the denominator. And cosine squared of x is now in the denominator. So, apologies, this should be squared. Now this can cancel, and we are left with 1 over cosine squared of x. And 1 over cosine squared of x is equivalent to secant squared of x. So our final solution will be secant squared x. Thank you for listening.